dealing with wave optics in continuation only. Third lecture of this, we have discussed about the interference and the previous class. It means superposition of two waves which are having the same wavelength, same frequency, moving along the same direction, and to get the better interference pattern, both should have the same amplitude as well. So today we are willing to find the expression for the fringe width. So what is fringe width? First of all, you should know that when we are getting this pattern, like we are getting the maxima and minima on the screen, so it means we are getting the equispaced your dark and bright lines. So these are the distance between two consecutive bright fringes that is termed as beta, which is the fringe width. So fringe width, that is beta, the distance between two consecutive bright or two consecutive dark fringes. So that we are willing to find when we are getting the interference pattern, we will be able to see like this. Of course, the width of the dark and bright fringes will be the same, and we get it like this. Like this is simply to understand the things. And if otherwise, if you go with the whole experimental arrangement, we take a single source, of course monochromatic light, laser beam I can take. I have this double slit arrangement with me, S1 and S2. They are separated by some distance, and the source we are trying to keep in its center. So if small d is the distance between both these sources, and capital D can be taken as the distance between the source and the screen. This is your screen on which we get the interference pattern. And this intensity graph is shown here with the distance. Here at O we are getting the maxima, it means bright light, then dark, then bright, and so on. This central maxima we are calling it as the center, means the which we are getting at O point, that is in the center, so we are calling it as the central maximum. So if we go on the upper side, or it means on the right hand side or on the left hand side, I may call it as the first bright, second bright. On both sides we can call it like this. So this is the experimental arrangement which we make. S1 and S2 are the two slits of same size. As I said, the slit width is quite small, as near 0.2 millimeter, while this between S1 and S2 can be 2 millimeter. Because here we have shown it a bit greater to make the diagram clear with you. This distance is not that much large. This S1, S2 means small d is quite small. It can be 2 millimeter. So that you should keep it in your mind. And then we are willing to see that if I'm taking the waves are coming, of course, wave fronts are being shown, one with the bold line, another with the dotted line, simply to differentiate crest and trough. And that we can continue that diagram I have already shared with you in the previous class. So basically today we are willing to find if supposingly at any instant of time I'm getting the waves which are reaching at supposingly point P. So at this point P, when I will get the constructive interference, it means maximum intensity, and under what condition I will get the minimum intensity. First that is clear, then I will be able to find the fringe width, which is the difference between the consecutive bright or consecutive dark fringes. So that is our aim in this very important expression of this. I want to find the fringe width, that is denoted by beta. Now at this P point, now of course you should be making the diagram first with your own hand. Capital D is the distance between the source and the screen. These two sources has to be there for interference pattern to take place. And this we have made the arrangement here at O point. This is equidistant. If I draw the perpendiculars on the screen like this from S1 and S2, they are meeting at points A and B. This distance OA or OB, that is equal, that is small d by 2. Small d is the distance between both the slits. Now, if I am taking this P point is here at distance small x from O point, I want to find this your position x, and then I want to derive the expression for this path difference. At P point, if I am saying the path difference means how much distance they are traveling. So first wave, which is starting from S1 reaching to P, second wave is starting from S2 reaching to P. What is the path difference? If you see from here the diagram, you can say that I can get it by drawing the perpendicular. I can find, this is also one way, I can find theta, and I can find S2n supposingly. But another way with me is that I find S2P and S1P. Of course, you can see S2P is greater than S1P. So I want to find the path difference, which is equals to S2N, that is given by S2P minus S1P. So I have to find the value of S1P and S2P to solve the mathematics, and for that sake I'm simply taking the help of this diagram. Of course, these angles are 90 degrees, these are perpendiculars drawn. So in the right angle triangles, I can find the value of the diagonal. So S2P, if I take S2P whole square, that will be equal to S2B whole square plus BP whole square. Now this S2B, it is equals to capital D, which is the distance between the source and the screen. And this distance BP, if you see, this is equals to X plus D by 2. And similarly, if I want to find S1P, I will take this triangle S1AP. And in this triangle S1AP, I will be finding S1P whole square, that is equals to S1A whole square plus PA whole square. Now this S1A, it is equals to capital D, while this AP it is equals to total distance X minus D by 2. So I am able to write this expression for the path difference, which is of course S2N, that is equals to S2P minus S1P I have to write, and I got the condition for path difference to get maxima and minima, that I will be putting here. So this is mathematics. You have to put the values for, I have simply calculated firstly S2P whole square minus S1P whole square. By putting the values, S2B is capital D and this is X plus D by 2 whole square. Similarly, if I put the value here, now this S2P whole square minus S1P whole square, A square minus B square, I can write it as A minus B into A plus B. So my aim is to find S2P minus S1P. So this factor S2P minus S1P I have to find. And if you work out this, of course, d square will get cancelled. If you open the bracket for this, x square plus d square by 4 plus 2xd by 2, it means xd only left. And here also, if you see this x square, d square by 4, these both terms will get cancelled. And minus xd minus of minus xd, I am left with 2 small x small d. This I am getting simply by solving. And from here, you can calculate this value of S2P minus S1P, which is coming out to be 2xd divided by S2P plus S1P. Now, because this capital D has to be really very large, distance between the screen and this has to be very large. So, when I want to get the bright fringe, this value yours, because it means S1P and S2P can be taken as capital D. It means this will become twice of capital D. If you wish, you can write here also that I may write this expression as because capital D is very large. So when I am taking this distance very large, then I may take this value as 1, here P as 2P when I am comparing, otherwise I may take it approximately equals to capital D. So under that condition, this path difference I am getting equals to twice of small xt divided by 2d. So this 2 will get cancelled and I am left with this path difference equals to xd upon capital D. And if I want to have the bright fringe, this path difference should be equals to n lambda. This we have done in the previous class as well. So this p should be equals to n lambda, and from here you can get this position x, this distance x, in terms of lambda, that is coming out to be n d lambda upon small d. And of course the values of n can be 0, 1, 2, 3. So it means for central bright fringe n equals to 0, it means x naught equals to 0. It means this position x, when I am taking here on the screen, from here I am taking, this is of course here's S1, S2, then this point is O point, where I am getting your n equals to 0, which is your central bright fringe. I will get here at O point. Similarly, if you go on this side, intensity is coming further greater. When n equals to 1, I am getting x1, it is equals to lambda d upon small d. That is the first bright fringe I get, and second bright fringe you will put n equals to 2. Then you are getting x2, it is equals to 2d lambda by d. So from here, if you want to find beta, beta is the fringe width. It means distance between two bright fringes. That is coming out to be lambda capital D upon small d. For nth bright fringe, if I want to write the expression, I will be getting n d lambda upon small d. So this is the expression with me for the nth bright fringe. So I will be getting bright fringes, and in between bright fringes I am getting the dark fringe. That also can be proved mathematically by taking this condition for path difference equals to, for destructive interference it should be equals to 2n minus 1 lambda by 2. But path difference we have calculated. Path difference, it is equals to small x small d divided by capital D. So from here you can get the position x, which is coming out to be 2n minus 1 d lambda by 2. Small d I am getting in the denominator. So when you are taking n equals to 1 x1 dash, it means first dark fringe I am getting it 1 by 2 capital D lambda by small d. And similarly second dark fringe I am getting x2 dash. Just simply to differentiate, I have named it like this. I am getting 3 by 2 d lambda by small d. So for nth dark fringe, if you want to write the expression, I am getting xn dash, which is equals to 2n minus 1 d lambda by 2d. So you need to keep these expressions for the bright and dark fringes with you, and then if you wish you can find the fringe width. So fringe width you have to find. That means we want to see the separation between two successive bright or dark fringes. It means two consecutive bright fringes, or it will be giving me the width of the dark fringe. Or similarly, if you take the separation between two consecutive dark fringes, it will give me the width of the bright fringe. So these are for the bright fringe. It means separation between two bright fringes, that is equals to xn minus 1, means nth fringe and n minus 1th fringe. I will put the value. This was the expression. Simply I have got, that is n capital D lambda upon small d. So this I am getting d lambda upon small d. This I can get by any two consecutive bright fringes. If I take, I will be getting this as the answer. Similarly, if you are taking for two dark fringes positions and you find the difference for nth and n minus first, then you put the value. Again, these results you can see we are getting the same. So the value of fringe width is same, that is equals to lambda capital D upon small d. This is the formula with you which you may use directly in the questions, that beta fringe width that is equals to lambda capital D upon small. This formula further we are using experimentally for finding the wavelength. In case if I want to find the wavelength of any source, then I can take the arrangement of Young's double slit experiment and I can find the wavelength. Or if I know even the wavelength, then this can be taken as the project that you can always verify whether the wavelength which you have calculated is coming out to be correct or not. So you can check the wavelength, or you can calculate the wavelength of a given source if you don't know the wavelength, by simply measuring the beta. Beta means fringe width, that is the distance between consecutive bright or consecutive dark fringes. Sustained interference, as I am saying, that I am getting the bright and dark fringes with me of same thickness. So the thickness of the bright and dark fringes, that has to be the same. If supposingly I am not using the coherent sources, then these fringes may overlap. And when they are overlapping, it means that is not the permanent pattern of interference I am getting. Rather, the pattern will means the colors will overlap over each other. So this is for sustained interference. I should be having all the conditions which we have discussed for interference, that should be there. It means sustained interference means the interference pattern in which bright and dark fringes, they remain there for a given interval of time. They should not be vibrating, or they should not be changing their locations, because if they change their location, then bright may come over dark and dark may come over bright, and then you will not be able to differentiate between the bright and dark fringes. So that interference, sustained interference, we may call it as the permanent interference also. To get the permanent interference, what are the conditions that you should know? Of course, I should be using the two sources which are continuously emitting waves of same frequency or wavelength. It means it should not happen that with the time the wavelength is getting changed. So I need such a source. Of course, two sources should be there that I can get either by the Young's double slit like I am getting, or I may use the Fresnel biprism, or by a large mirror I can take the two sources by any of the method to get the interference pattern. And maybe you people have noticed the interference pattern in day-to-day life also, like we are able to see the colors of a thin film when some oil is sprayed on the water. You are able to see the colored fringes, and that can be even if I use the white source in place. It means if I am using the white color, means white light as a source, then I will be getting this interference pattern. I will not be getting bright and dark, but I will be getting the colored pattern with me, in which the central fringe may come white and then say violet, because lambda for the violet is less. So accordingly, I will be able to get means that are beautiful interference patterns, not in your syllabus. So, but of course, because you should be having the idea about the things around you when you are able to see the interference pattern. So, like in thin films, when you spread the oil on the water, you are able to see the interference pattern because of the two sources. They are automatically getting formed, like one source from the upper surface you are getting, and second source by the reflection it is coming, because they get the same wavelength, and you are able to see the interference pattern. So the first condition for interference pattern to get is that I should be having the two sources which should be of the same frequency or same wavelength. So that is to get the bright and dark fringes. Otherwise, I may get different type of interference patterns, and I may not be able to find the fringe width in a proper way. Second point with you, that two sources of course should be coherent Coherent means there should be having all the qualities same, and they should either move in the same phase or they should be having the constant phase difference. And of course they should be having the equal amplitudes, because if they are not having the equal amplitudes, like one is having the amplitude this and the second is having this amplitude, then your dark fringe will not be completely dark. It will not be, means because these are not cancelling each other magnitudes. So I may get the resultant wave like this by the superposition of waves. So I will not be get complete darkness. But if these both the amplitudes are same, then I will be getting the complete dark. Dark will be complete dark fringe, and then bright will be completely, means more bright rather, as compared to if I am having the different amplitudes. So it means both of the sources should have same amplitude. Of course it should be narrow, because if they are not narrow, then the bright and dark fringes, they will not be able to get separated, means you will not be able to see them separated from each other. So they may overlap over each other. So it should be, of course, that is why I said when we take the slit, that is nearly 0.2 millimeter. So you can assume, means how narrow we are taking the source. It should be monochromatic, because if it is not monochromatic, as I've said, many wavelengths, if it is having like white light, it is having many wavelengths, then I will not be getting bright of the same width, because they will be again of different width and different colors on both the sides for some time you may see, and then they may overlap over each other depending upon the distance how you are maintaining. So monochromatic means single wavelength. We are using single wavelength, that source we will be calling it as the monochromatic source. They should be in the same state, it means phase can have the constant phase difference. Distance between the sources should be small. Of course, that is distance between S1 and S2 we are talking about. So if this is S1, this is S2, this distance, as I have said to you initially also, this is nearly 3 millimeter, and this distance, source, this is equals to 0.2 millimeter, nearly I'm saying. So this is just to see, means narrow means this distance, point source, how much it is width of the slit. Means slit width should be less. And when I'm saying distance between the two sources should be small, it means S1 and S2 should be very close to each other, like nearly 2 or 3 millimeters. So they are not that apart, as I have shown it in the diagram. Diagram is drawn to simply make you the things clear, mathematics clear. And of course, if they are not traveling in the same direction, then of course you will not be getting the interference pattern, because they will not be superimposing in that way, whatever way we wish. So of course they should travel along the same direction. So all these are the conditions with you to have the sustained interference. You can calculate lambda experimentally for the source of the intensity, maximum intensity, minimum intensity, that is taken by the amplitudes. So if A is the amplitude, this is again very important formula, that I maxima upon I minima if I want to find. What is I? I is directly proportional to your A square. That you should remember. And when I am taking two sources, A1 and A2 are the amplitudes, like the equation we supposed. And if I am taking same amplitude to get a sustained interference, then A plus A. Like we are having the formula with us that we got, that is equals to root I1 square, root I1 plus root I2 plus 2 root I1 I2 cos phi. This we got the formula for the resultant intensity. It means amplitude I got A equals to A1 square plus a2 square plus 2a1 a2 cos phi. So from there you can take the this I maxima upon I minima, that is equals to a1 plus a2 whole square divided by a1 minus a2 whole square. Minimum means subtract करके, and then for maxima you are getting by adding, minima you are getting by subtracting. Or I can rewrite this equation as a1 upon a2 plus 1 divided by a1 upon a2 minus 1. And this a1 upon a2, I am calling it as the interference ratio R, and this R I may write it as this equation as R plus 1 whole square divided by R minus 1 whole square. So I can write R equals to a1 upon a2, which is equals to square root of I1 upon I2. I1 means I maxima, I2 means I minima, here I am taking. So that way you are able to see this interference ratio R. You should be able to compare intensity with amplitudes for solving the questions. So keep things up to this for today. Thank you everyone.